Hey there, from here, Ali. It's time to tune MST as I promised you in the previous video. So in this video, I'm going to implement and tune MST in 3 different types of topology. Well, actually, I wanted to tune MST in one topology only, but some guys, well, now they're my friends, text and ask me to implement and tune MST in more topologies. So I decided to add 2 other scenarios, so this video might be longer than ever because of that. The first topology is a very small and easy one to be familiar with commands and its mechanism. And the second one is a tree topology for the network specialists who have tree topology in their job. And the last one is a full mesh topology, which is much more complicated. So there's so much fun. I don't want to talk too much, so let's quickly jump into the laboratory. Guys, before going to laboratory, you need to know 2 important points about MST. Number 1, in MST, whatever switches you want to join to the revision, they're gonna be assumed as one switch in the topology. And if you connect other switches with PVST, for example, it is possible. Interesting, right? And point number 2, you never map any VLAN into instance 0, which is created by default, because of the misconfiguration that is indicated by the CCNP syllabus. So you must always create MST instances and map your VLANs to it or to them. We will cover it in the scenarios completely. Alright, we firstly start from the easy scenario. We got 3 switches, layer 2, and I have created 30 VLANs in this scenario. And if you show VLAN in any switch in this scenario, you can see 30 VLANs are created, right? So the first thing we have to do is to figure out what switch is the root bridge, right? So if I go to switch 2 in here, which show spanning tree, guess what? Root. With the keyword root, you can figure out that this switch is a root bridge or not for VLANs. So you can see root cost is 100, which means that this switch is not a root bridge for VLANs. And another switch which shows spanning tree, root, you can see root cost is 100 as well in this switch. So we figured out that switch 1 is our root bridge, which show spanning tree root. You can see root cost is 0 for all the VLANs in here, right? So this switch is our root bridge. Let me write down in here, bridge. Great. And because this switch is root bridge, both ports are designated ports, right? Because this is a root bridge. So these ports are designated. And if I want to capture BPDU packets, I'm going to do that from these ports, right? So guys, we learned in the previous video for each VLAN we have 1 STP. As a result, we have 30 STPs in this scenario, which is many, and it may cause problems because of the BPDU traffic. And if I want to capture this port in Wireshark, I'm going to filter to STP. You can see there are many BPDU packets are being calculated in all the switches in this scenario every 2 seconds, guys. So what's the solution? Guess what? Solution is MST. I'm going to write down the MST configuration commands in here in the banner, and then I'm going to input all of them into switches. First of all, we need to change spanning tree mode to MST with spanning tree mode MST. And then we need to get into MST configuration mode with spanning tree MST configuration. And then we need to specify a name with the keyword name. Listen guys, region name in MST is key sensitive, and I strongly recommend you to choose your name all lowercase. in order to be able to troubleshoot easier in the future. So I, for example, choose CCMP. Easy, and all words are lowercase. And then guess what? Revision number with the keyword revision, right? Whatever number, as I told you in the previous video, revision number and region name must be the same in all switches in their topology, right? So I name it 1, and then I'm gonna create instance with the keyword instance, for example 1, and then with the keyword VLAN you can map any range of VLANs into your instance. For example, in this case, instance 1. I'm gonna map VLANs 1 to 10. Listen, as a network architecture, you need to consider everything such as network condition, the number of VLANs, and also the number of switches. The best choice in this case is dividing VLANs by 3, mapping them into 3 MSTI or MST instances to specify each switch as a root bridge for each MSTI to use maximum of capacity. So I'm going to create 3 instances or 3 MSTI. Instance 1, instance 2 with mapping VLANs 11 to 20. And then the last instance is instance 3. Range of VLAN is 21 to 30. All VLANs, right? Now I'm gonna input all of the configuration commands into each switch. I start from switch 1. All right. First action is a spanning tree mode MST. With this command, as I showed you in the previous video, let me show you. With show spanning tree mode spanning tree MST configuration. With this command, all of the VLANs are going to be mapped into the instance 0, which is created by default with this command. As I just told you, mapping your VLANs in the network causes misconfiguration and problems. So you never ever have to map your VLANs into instance 0, right? Let's go back to business. And oh, I remember we do show spanning tree. You can see spanning tree protocol is now MSTP, right? Great. And then we're going into MST configuration mode with spanning tree MST configuration. After getting into configuration mode, we have to specify our name. In this case, I'm going to specify this name to CCMP. And also revision number. Revision number 1. As the banner says, I'm going to create 3 instances or MSTI. Instance 1, VLAN 1 to 10, instance 2 for VLANs 11 to 20, and instance 3 for VLANs 21 to 30. All of the VLANs are covered now. At the end of the action, we have to, oops, I forgot about that, exit. Exit is so important, guys. If you don't input your exit, the changes are not going to be saved anyway. So with show pending, as you can see, from instance 0, all of the VLANs we specified are removed from instance 0, right? With exit, all of the changes are going to be saved. And then with end and show spanning tree or MST configuration, here we are. Revision name, CCMP revision number is 1. We created 3 instances and we mapped all of the VLANs into them. And the thing we have to do is to input all of these configuration commands into the rest of the switches. So I'm going to speed up the video for not wasting your time. Alright, now all of the switches are configured properly. In the next step, we have to figure out what switch is a root bridge. I want to start from switch 1, which show spanning tree root. Here we are, guys. You can see the MSTIs, right? All VLANs, the 30 VLANs are mapped into reduced MSTIs. MST1, MST2 and MST3, and you can see the root cost all are 0. So it means that switch 1 is a root bridge for all of the MSTIs. So if you remember the previous episode, what we did in that video, we're going to do the same in this scenario. We're going to change the root bridge for each MST to use the maximum of capacity. To do that, let me write down for each switch, for example, MST1. Switch 1 is root bridge for MST1. Switch 2 is a root bridge for MST2. And switch 3 is root bridge for MST3. Great. I'm going to start from switch 2 to change the root bridge for MST2. To do that, we input the keyword spanning tree and then question mark. You see the MST. So we input MST and the number of the MST, right? It is 2 for switch 2, right? So I'm going to change MST2 root bridge and with priority and root. I'm going to set root bridge for this MSTI with priority because defining priority 0 is much more secure. Well, with priority and the number of priority, guess what? 0. And this switch, let me go back and show spanning tree root. You see that switch 2 is a root bridge for MST2. Great. I'm gonna change the root bridge for MST3. Config 2 we do the same, guys, with spanning tree MST and what MST? 3 and priority number 0. This switch is a root bridge for MST 3. Show spanning tree. Show spanning tree root. You see that, guys? The MST 3 is a root bridge. The switch 3 is a root bridge for MST 3. Great. In the next step, we need to check out the connectivity among the switches with assigning IPs to the VLANs in each switch. Before assigning IP, let me capture the packets, BPDU packets, to see whether they're working properly or not in Wireshark. I'm going to filter the packets with STP. You see that, guys? The BPDU traffic is working properly. It is nicely working with no problem. That is awesome. And in the next step, I'm going to assign IP to the VLANs, and then I'm going to ping other VLAN IP and capture ICMP packets to see what the link they're going through. All right, let's go. All right, now the IPs are assigned successfully. It's time to check out the ICMP. Let's go to the switch 2 with ping 192.168.10.11, VLAN 10 in switch 3. All right, as you can see, it can see switch 3 VLAN 10, and let me ping another VLAN 30.11. Great. It's time to capture the packets. Are you ready? And with ping 192.168.10.11. Let's go. Let's capture this link. ICMP. All right, as you can see, the VLAN 10 packets do not go through this link. It's supposed to go through that link. Let me stop this. Ping VLAN 10 in switch 3 again, and capture the packets in this link. ICMP. Again. You see that, guys? The ICMP packets are in VLAN 10 are going through this link, right? And if I ping, let me stop the capture. And if I ping another VLAN, ping VLAN 30.11. Let's go. ICMP. Again. You see that? VLAN 30 go through this link directly connected to MST3 and switch 3. Alright, they're nicely working, guys. We're done with this scenario. Now we can use the maximum of capacity in this scenario. Let's go to the tree topology. Alright, now the tree topology. We have created 40 VLANs in this scenario in each switch, and as a result, you tell me how many STPs we have. Right, 40 STPs. And another thing, as always, we need to figure out what switch is a root bridge, right? So I'm going by random, going into one switch, for example, switch 2 with show spanning tree root. There we are, root cause. This is not a root bridge because the root cause in each VLAN is 100, right? So this is not a root bridge. I'm gonna check core switch because I assume core switch is our root bridge, which show spanning tree root. As you can see, this is the root bridge for all the VLANs because the root cause is 0, right? From 1 to 40, all the root cause is 0. So now we know our root bridge in this scenario. And another thing we have to check is a BPDU traffic because we know we have 40 STPs in this scenario, and I want to make sure that we have BPDU traffic every 2 seconds from 40 STPs. So because we know this is a root bridge, all these 5 links are designated, right? So no difference what link we capture the packets, but all of them are sending BPDU packets every 2 seconds from 40 VLANs, 40 STPs. So I'm gonna check this link with capture the packets in Wireshark. I'm gonna filter the packets with STP. You see that, guys? PBSD plus, and the packets are being sent every 2 seconds all the time, guys. There are many BPDU packets. So we have a problem because the problem is negatively affected on performance of the switches and also on RAM and CPU usage. Let me stop capturing the packets first. So now my question is, what's the solution? Right, MST. In MST, we can map all the VLANs into reduced MSTI, right? So as always, I'm going to write down the configuration commands in the banner and then input them into switches. So first of all, we need to change the spanning tree mode with spanning tree mode MST. And then we need to go into MST configuration mode with spanning tree link tree MST configuration. And then after going into spanning tree configuration mode, we need to specify a name that as I told you before, this name is key sensitive. Try to choose your name easy and all lowercase because it is hard to troubleshoot in the future if you choose a hard name. For example, I name it CCMP as well. And then guess what? Revision number, right? Revision number would be, I assign this to 1 again. And then we need to create our instance. Instance, for example, 1. So guys, listen, in this scenario, because we don't have any distributed switch, we have to define our core switch, the root bridge. When you don't have any distributed switch in your topology, you shouldn't define an access switch, a root bridge. It is totally wrong, guys. So in this case, because we have only one core switch, I'm going to create one instance only. So I'm going to instance 1 and map all the VLANs from 1 to 40 into instance 1, right? With VLAN 1 to 40. And then guess what? With show pending, you can see the changes, and after making sure, you can save the changes with exit and write. Alright, I'm going to input all of these configuration commands into each switch. I'm going to start from core switch in here. Open the SSH. Right. And going to first of all changing the spanning tree mode. Spanning tree mode MST. And after this command, as you know, which shows spanning tree, MST configuration, you can see that all the VLANs from 1 to 4094 are mapped into instance 0 by default. After changing spanning tree mode, we have to go into MST configuration mode with spanning tree MST configuration, and then specify the name, which is CCMP. And then guess what? Revision number. With revision, the number is 1, and it has to be the same in all switches in your topology, as you know. And then we're going to create our instance. Instance 1 VLAN. We're going to map VLANs 1 to 40 into instance 1 to 40. And with show pending, you can see the changes. VLANs 1 to 40 are mapped into instance 1. So all is good. With exit, changes are going to be saved. End and write. I'm going to be the same in all switches. As always, I'm going to speed up the video, not to waste your time. Alright, now all of the switches are configured, and in the next step we need to figure out what switch is a root bridge for MST1, right? I guess core switch is a root bridge. Let me figure out with show spanning tree root. Here we are, MST1, root cost is 0. So core switch is a root bridge. But guys, my question is, what if an access switch would be root bridge in this scenario? Well, we change the root bridge to core switch immediately with priority. So we're going to core switch. If an access switch would be root bridge, we're going to core switch, and with keyword spanning tree and MST, we have word MST instance. So what is the number of our instance? It is 1, right? And then we have priority or root. I'm going to use priority because of the security. So MST1 priority, and guess what? 0. And then core switch is the root bridge in this topology, right? You got it? In the next step, we need to capture the packets that if the problem, BPDU problem, is resolved or not. So I'm going to capture this link. Start packets in Wireshark and STP. You see that, guys? The BPDU packet problem is completely resolved with MST. Great, all is great. It is nicely working, guys. And another thing I have to check is ICMP. Let me stop capturing the packet in this link. All right, the other thing we have to check is ICMP. So I'm going to assign IP to switch 5 and then assign IP to switch 1 for VLAN 10, for example. And I'm going to enable IP routing in core switch and then checking the ICMP. It is working properly or not. So going to switch 5 and going to interface VLAN 10, IP address 192.168.10.10, prefix /24 with no shot and end. All right, it is assigned, guys. The IP is assigned successfully. And then going to switch 1, we do the same. Going to interface VLAN 10, IP address 192.168.10.11, prefix /24, right? With no shot. And in the next step, we're going to core switch and enable IP routing for SPI. For configuration terminal, with with IP routing, you can enable routing in the core switch and write. So if I go to switch 5 and ping switch 1 in here, 192.168.10.11, I'm going to firstly capture the packets in this link. Filter the packets to ICMP. Here we go. It is working. It is nicely working, guys. The connection is okay. And let's go to the Wireshark. There it is. These are the ICMP packets that are conducted to switch 1 through core switch, right? It is nicely working. At the end, I'm going to check from switch 1, ping 192.168.10.10. As you can see, the connection is okay. And if I go to Wireshark, you can see the ICMP are being conducted to destination with no problem. Alright guys, now the tree topology is perfectly working. It is time to go to the full mesh topology. Alright, let's go. Alright guys, finally, it's time to implement and tune a complicated topology which can be vulnerable and powerful at the same time. Guys, one of the requirements to have a topology like this is implementing and tuning MST properly. So if you want to have a network like this, you need to be expert in switching contents. I'm going to give you a configuration and architecture in order to get the best performance from your switches. Now, I have created 40 VLANs. And now, as always, we're gonna figure out what switch is the root bridge. So we're going to distributed switch 1, D1 switch, which show spanning tree root. You can see this is not the root bridge because the root cause is 100, right? I guess that core switch layer 3 is our root bridge, which shows spanning tree root. Here we are. This is the root bridge for all the VLANs. All for the VLANs, this is the root bridge because the root cause is 0, right? And now another thing we have to check is the BPDU traffic with capturing the packets. So we know this is a root bridge for all VLANs, right? So the ports are designated ports. So the BPDU packets are being sent from these ports. Now I'm gonna capture the packets, start capturing with Wireshark. I'm gonna filter the packets with STP, which is BPDU. You see that, guys? There are many BPDU packets that are being sent every 2 seconds from 40 VLANs, 40 STPs every 2 seconds. And all of the switches are calculating all the time. So this is one of the problem in this topology. Let me close this first. Is addressing the problem with too much pressure on switches by BPDU packets. And also another thing we have to deal with is to use every single link among the VLANs in order to reach to the maximum of capacity. So what's the solution? Well, MST. I'm going to write down the configuration commands as always, and then I'm going to input all of them into all switches. So the first thing we have to do is changing the spanning tree mode, right? With spanning tree mode MST. And then guess what? Spanning tree, we need to go into spanning tree MST configuration mode, right? With spanning tree MST configuration. Now we are in configuration. Now we are in MST configuration mode. And then we need to specify a name that, as I told you several times, that this name is key sensitive and you need to specify an easy name, because if you choose a difficult name, it's hard to troubleshoot later, right? So I'm gonna specify CCNP as well. And then guess what? Revision number. And as I told you several times either about this revision number, whatever the number you specify, you have to specify the same revision number and region name for all the switches, in all the switches. So I'm gonna define one, and then it's time to create instance with keyword instance and the number of the instance. All right. Listen, guys, in this scenario, we have two distributed switches, which means that the topology has the potential to have two root bridges, right? So we can create two MSTI or MST instances to define root bridge for each of the distributed switches. Now I'm gonna create instance 1 with VLAN. Now I'm going to divide the VLANs by 2, so we can map 20 VLANs into each instance. Now for instance 1, I'm going to map VLANs 1 to 20, and I'm going to create another instance or MSTI 2, and VLAN, I'm going to map 21 to 40 into instance 2, right? And then guess what? We show pending. You can see the changes, and then with input exit, the changes are going to be saved, right? Now it's time to input the configuration commands into the switches. I start from switch core. I input the configuration files one by one. First of all, we need to change the mode to MSTP. Mode MST. And then getting to MST configuration mode with span tree MST configuration. And after getting to configuration mode, we need to specify a name, CCMP, right? And then revision number. As the banner says, it is 1. And then we need to create our instance. We have 2 instances. So I'm going to map range of the VLANs 1 to 20 into instance 1. And another instance, number 2, the VLANs 21 to 40. And then with show pending, you make sure that the configuration changes are properly configured. As you can see, instance 1, VLANs 1 to 20, and instance 2, the VLANs 21 to 40, right? And with input exit, changes are going to be saved. Alright, as always, I'm going to input the configurations into the rest of the switches. So now I'm going to speed up the video not to waste your time. Alright, now I input all the configuration commands into the switches. Now it's time to figure out what switch is the root bridge for instances. I guess the layer 3 is a root bridge for instances with show spanning tree root. As you can see, the layer 3 core switch is a root bridge for MST1 and MST2 because the root cost is 0 still. But guys, we don't want our core switch root bridge, right? Technically, it's not totally right. We plan to make our distributed switches root bridge. So I'm going to make D1 root bridge for instance 1, and then I'm going to make D2 root bridge for instance 2. For this purpose, we have to go into the switch. And then in the configuration mode, we have to input spanning tree, MST, and then we have to input the instance number. For example, we are in D1, so the instance number is 1, right? We have two options. We can go through the priority line, or we can input root and primary. So because of the security purpose, I'm going to input priority with the number 0. And if I show spanning tree root in D1, which is our root distributed switch, here we are. This switch is now our root bridge for MST1. It is successfully set, and it is time to, let me save, and it is time to configure D2. In configuration mode, spanning tree, MST, what the instance number? Instance 2, right? With priority number 0. And if I show spanning tree with root, you see that MST2 root bridge, right? So it is successfully set. Now it's time to finish the final rounds. We need to check out two components to make sure that this topology is nicely working and we optimize the network properly. Number one is checking BPDU packets that are being sent from our root bridges, right? And number two is checking the connection among the switches from VLAN with ICMP, with assigning IP in each switch for VLANs, right? So first of all, I'm going to capture packets, BPDU packets from our root bridges. We know that distributed switches in this scenario are our root bridges for MSTI1 and MSTI2, right? So I'm going to show spanning tree in distribute 1 switch. Show spanning tree. If I coming down, in MST1, as you can see, this is a root bridge, right? And if I check the ports are connected are 2/2 until 3/3. These ports, right? These are connected to other switches. So all of these ports are designated ports. So the BPDU packets are being sent from these ports. And if I go to distribute to switch, show spanning tree, looking for MST2, as you can see, in MST2, this is the root bridge, D2. And if I coming down, the ports from 2/2 until 3/3, all of them are designated ports. So no matter what port we capture BPDU packets, because all of them are designated. So I'm going to, for example, I don't know, capture this port. Start capturing BPDU packets in Wireshark with SDP. You see that they are working decently. They're nicely working. So too many BPDU packets are resolved by tuning MST. And if I go, let me stop the capturing from this port. And if I capture packets, for example, this link, you see that, guys? The BPDU packets are decently working. All right. The second thing we have to check is the connection among the switches. So now I'm going to assign IP for VLAN 10 in A1, and then assigning IP in core switch, which is our layer 3, and then at last I'm going to assign IP for VLAN 10 in A4, which is the furthest switch from A1, right? I'm going to A1. Interface VLAN 10, IP address 192.168.10, 10 with prefix 24, no shot, and going to layer 3 switch, do the same. Let me write down the IPs beside the switches. 10, 10 for A1. 10, 11 for core switch. And 10, 12 for A4, which is the further switch from A1, right? Now, going to interface VLAN 10, IP address 192.168.10.11 with prefix 24. Oops. No shot. Going to assign in A4. Interface VLAN 10, IP address 192.168.10.12, prefix 24, no shot. All right. All the IPs for VLAN 10 are set successfully. Now I'm going to A1, and for the first step, I'm gonna ping 192.168.10.11, our core switch in here. So I'm going to capture packets from here because the packets are supposed to go through this link, because the nearest link is this link. We optimized this topology so the packets go through the nearest link, right? And I'm gonna filter the packets. So guys, you can see this STP, right? They are nicely working. I'm gonna filter ICMP. And if I ping 192.168.10.11 core switch, all right, the first action is the ARP. So we have to wait for, right, the connection is okay. And if I ping again, you see that, guys, the connection is nicely working. And if I go to Wireshark, you can see the request, ICMP packets that are being sent from this link, which is the nearest link from A1, right? And I'm gonna ping another thing from A4. I'm gonna ping core switch from A4. So capturing this link, you see the ICMP packets, they are resolved, they're working properly. ICMP. And go to A4 with ping 192.168.10.11. You see that the connection is okay. And if I go to Wireshark, let me see. I close all this. And again, ICMP. I expect the packets go through this link, guys. So I'm gonna ping again. So as a result, as you can see, the packets, ICMP packets, are not going this link. So I'm gonna capture this link. Let me close the Wireshark and stop this first and capture this link. All right, ICMP and ping again. All right, it's not going through this link either. So again, I'm going to close this, stop capturing this link, and capture this ICMP, right? And if I go to A4 again, ping the core switch, you see that, guys? The packets are going through this link. It's like a map, guys. The packets are finding the best way to reach the destination. Better saying, the best way is this link. Alright, the ICMP packets are working properly. Another thing I have to check is to check that we see the furthest switch, I mean A4 from A1. So if I ping 192.168.10.12, the connection is okay. And if I capture, for example, I think that they are going through this link. Let me see what port they are going through. ICMP. Again. So this is not the ports that the packets are going through. So stop capturing packets. And I think their packets are going through this link. Let me capture this link. ICMP. Ping A4 again. Alright, you can see the request. The ICMP packets are going to A4 through the nearest link, guys, which is the next which is D1 and then A4. So we optimize this topology properly. Now this topology is done successfully. Thank you guys for watching. I hope you enjoy that. Please subscribe me to motivate me to make more videos. See you soon.